Hello, welcome to the first class. This is Math 208, College Mathematics for Business, Economics, and Life Sciences. For the most part, we're going to be following through this book. You should have it. We're using the 14th edition. Anyways, I'll introduce myself real quick and then we'll get right to it. I'm Gary Dalton. I will be your guide on this course. You can refer to me in emails, etc., as Professor Dalton, Teacher Dalton, Mr. Dalton. Any of those are fine. Um, I think today we should just get started. I'm going to turn off my imaging for me. We'll leave the document camera on, and we'll go through these notes. So we do have some items that we will generally be looking at. And some of this I'll cover when I'm doing the discussion class, and some of it I'll do in the lecture class. For the lectures, I'm mainly just going to go straight into the topic for the day, and that topic for today is sections 3.1 and 3.2 from the book. And we're going to find unknown values using the formulas for simple interest, compound interest, and let me change my thing up here, and continuous compound interest. So these items right here. We're also going to have to recall some of our logarithm rules. And then we're going to state and apply formula for annual percentage yield, which is a way to make comparisons between some of these. For simple interest, and this is section 3.1 in the book, interest is the cost of using money. When you borrow money, you pay interest. When you lend money, you earn interest. Simple interest is basically the foundation for the other interest types. In real life, it's mostly used for terms up to about 1 year. At the end of the term, the interest is paid along with the principal. We have some pretty basic formula for that. The interest, I, equals the principal, or present value, times the rate, and this is a decimal annual percentage rate, times the time in years. Another way to write this out is the amount, or the future value, equals the principal plus the interest, which is what we have here. And we're going to be working with three formulas, and I have those numbered, 1, 2, 3. So the interest, the amount or future value, which is indicated here, and then equals the principal. These two equations are basically the same. And there's a couple terms here. Amount or future value, that's how much money you will have in the future. The principal or present value is the amount that you start with. Interest rates are always converted to decimal form before we use them in formulas. It's just the appropriate way to do things. And right off, this is really, for the most part, pretty simple stuff. So let's just do some of the examples right away. And these are examples from the book. Problem number 50. Normally I'm going to separate the examples from the main lecture part, but for this first section I'm not going to do that. So we start out with problem number 50 from the book. If $5,000 is loaned for a term of 9 months at 6.2 annual percent, how much interest is earned? And it's a simple application of the formula, formula 1. If we look at this, formula number 1, and that's I equals PRT, present value, decimal rate. The values that we're starting with are 5,000. We convert all of our interest rates to decimal right off, so 0.065, and in 9 months is 3/4 of a year. So times 3 over 4. So T is, remember, T is in terms of years. 9 months is 9 divided by 12. Doing the calculations, we end up with 232.50. Like I said, it's a pretty basic application of it. We're going to do problem number 40. And in this one, we're given some different values. So we're given a amount, a future value. So we're given a future value, a present value, and an interest rate. We want to know how long it takes. What is the time? How long will it take to achieve a certain point? So for this, we're going to use equation. We could use equation number 2 or number 3. Most of the time, I'm going to use equation number 3, depending on most of the time I'm going to use equation number 3. So that's what we're going to use in problem number 40. And equation number 3 is the amount, 1 plus RT. And I like to manipulate my formula before I plug in the values. I find that it's a little bit easier to do. You do not have to do it that way. I'm going to generally do it that way because it allows you to reuse some of the results that you've calculated. So we have A divided by P equals 1 plus RT. And we do that by dividing both sides by P. So 1 over P, 1 over P. Now, and what we're trying to find is, recall, is T. So now we have A divided by P minus 1 equals RT. And then we're looking to find T. So 1 over R times A divided by P minus 1 equals T. And that is the formula that we have indicated basically right here. Right here. Sorry about that. I don't know why it's not doing this right. Okay, well, we'll do it a little differently. I have multiple ways to do this, so let's do it this way. That's basically the formula we have right here. So once we're at this point, we just basically plug in the numbers that we're given, which in this case is the 410 is the A. So A is equal to 410. P is equal to 400 minus 1, and then again we convert our 10% to 0.1, so we divide this by 0.1. We do the calculations, and T equals 3 months. Additional to these problems, when you're looking through this for homework, I would highly recommend looking at example number 6 in the book. That's on page 131. That'll help you with 1 or 2 of the homework problems. That's it for today. Thank you very much.